Ta-da. Hello everyone, my name is Majid and welcome to another video of Topics Basics. Sometimes you want to use your freezer to cool down your canned beer pretty fast and then you forget about it for some time. Let's say 1 or 2 days, and after that your canned beer might not be drinkable anymore. Or you're on a road trip in a cold winter day and would like to have some beer in your car. For example, going to a cozy winter cottage here in Sweden. Or even traveling between different cities or countries and buying some beer from there. This might be of interest because of different options one may have or different price tags. This might be a very usual thing to do, but a can of beer cannot survive cold temperature for a long time. So why beers cannot survive freezing temperatures? This is also true for other beverages like cola, which have similar ingredients. To explain this, I do an experiment, which is simply putting a can of beer inside liquid nitrogen. I did this experiment 3 times, which had 3 different results. These results were used to explain why this phenomenon happened based on different ingredients that are inside the can of beer. Now when my Tuborg beer goes in, we will see what will happen. And it's like boiling all the time, liquid nitrogen, because of course, the temperature difference. After 3 minutes and 50 seconds, it happened. I heard the crack, but couldn't actually record it on the camera because of my bad setup. As you see, it got a pretty clean cut on the edge. Everything inside the can was frozen once, and then it got cracked. But the footage was not satisfying, so I changed the setup. I found a box in our lab to put the beaker inside it and then left the whole thing outside the fume hood. The released nitrogen gas just goes up and then it is less foggy around the beaker. While I'm preparing for the setup, now it's the time for you to subscribe to Topics Basics. Press the subscribe button, then you will not miss any video from us. It went on for over 5 minutes without any noticeable noise of cracking. That meant that according to previous time, it should have been done already. So I checked it and apparently it is frozen and deformed, but without any cracks. A possible explanation for this can be that just before the experiment, the can fell down from the table and some percentage of the gas was released. Maybe. The sign of the falling down is still there. Well, not so good. This meant I am due for another time. But this time it was perfect. First, watch this. Oops. Uh-oh. You saw that? Just explode. The third time, after 3 minutes 33 seconds, it exploded. And after 2 seconds, leftover, which were still liquid, came out of the can and got frozen outside. To explain why this happens, one needs to look at what is inside a can of beer. More than 90% of beer is water. So in freezing temperature of liquid nitrogen, it will be frozen. When it's solidified, it will expand. Inside a can of beer, we have limited volume. So it will put an extra pressure from inside, which ended up in a splitting or explosion in some cases. Another ingredient is gas beer, the gas which is inside beer and gives this popular beverage the distinct element of bubbling. Everybody loves it. It's a mixture of nitrogen and carbon dioxide, but mostly carbon dioxide. So when water is frozen, carbon dioxide can be in gas form or already solidified. Let's assume it's in a gas phase. So inside limited volume of can, water is frozen and expanding, and carbon dioxide in gas form also looking for an escape from the pressure. So it puts an extra pressure on the can, which enhances the process of splitting or explosion. To understand phase of carbon dioxide better, one needs to look at its phase diagram. I have it here. It shows in different pressure and different temperature what is the phase of carbon dioxide. Let's look at here. So on y-axis I have pressure in atmosphere, on x-axis I have temperature in degrees Celsius. And here are different phases: gas, liquid and solid. So in 1 atmosphere, carbon dioxide needs a temperature of -78 to be solidified. But inside can we have around 3 atmosphere pressure. So a little bit lower temperature needed to be solidified. But inside liquid nitrogen, we might be around here in temperature side. So solidification is more possible. But back of your car, inside of your fridge, or back of a smuggler car, we might be around here from temperature side. So carbon dioxide is more probably in gas form and put extra pressure on the can. So a splitting or explosion is more probable. So this was for today. If you liked the video, please consider subscribing. Just press here and subscribe to Topics Basics. Let me know in the comment section below if you have seen this happens. Any other question or comment is welcomed. And finally, thank you for watching and see you in the next video. Cheers!